Hey everybody, welcome to this lesson today. I apologize, I'm not with you today. The expectation is that you are watching this video and you are completing the lesson. This is one of those rare instances. I may or may not, you don't know for sure. I may go into your lessons, and if I see that you skipped most of the lesson or you didn't write anything down, it may be an assignment that you're missing. And I honestly will tell you, I don't know if I will. I don't know if I won't. So just make sure you do the right thing and you work through these problems. So go ahead and pause the video while you solve these 4 problems. All right, so we're going to go through these. I'm hoping you pause the video, and again, please do the right thing and give these an attempt. So if you need to pause the video once more because you didn't really try, please do so. All right, so when we look at what the answers are, let me grab a pen. Let's go here. So when we look at 4 squared, what you're really doing is you're taking 4 times 4. So when you look at that, your answer is 16. Now if we go down here, and if we take 13 times 13, what do you get? And you can use a calculator for this. You don't have to use, well, you could work it out by hand if you want to, but you should come up with 169. Is that what you came up with? Good. So if you came up with 169, you're correct. So let's look at what these symbols are. So these, we're trying to find the square roots. These are the radical symbols, and this is the radicand. So let me grab a different color here. So if I'm looking at 121, what I'm trying to do now, first of all, you could put it on a calculator, and you could calculate this. But what you're really trying to do is find one number that if you multiply it by itself, it should equal 121. So, and if I do that, the square root of 121 is 11. So when I look at this number, you're doing the same thing, except it's going to be a fraction. So what number multiplied by itself equals 16? And if you're thinking, oh, it's 4, because 4 times 4 is 16, you're correct. And what number, when you multiply it by itself, equals 25? You're thinking it's 5. You are correct, and there's your answer. All right, so the next thing I want you to do is the same thing we always do. Pull out your review preview and check your answers. Now, if you look on Infinite Campus, a lot of you did not get credit for this. You didn't show me your work. And even if you just copy down the answers right here, it may not be enough because you have to show me how you got the work. So when you do A, B, and C, I am looking for your work. So on your problem, and I know yours are lined up differently, I should see the steps that you took. What's the equation that you use? And did you also get it right? So getting it right is half the battle. But remember, we talked about this. If you get it right, but yet you don't have any work, how can you prove that you did it and that you know how to do it and that you just didn't either guess or copy? So your work is that proof. Now up here, what a lot of you did, you didn't read the directions. It says determine which pair of lines, if any, are parallel. So for example, if 2 and 7 are equal, that must mean they're both alternate interior angles, which means this is the transversal. So C and D are parallel. So C and D are parallel. So that's really what it's asking you for. So a lot of you, I don't know what you did or what you read, but that's what it's looking for. So I'm looking, did you have that C and D are parallel? And this is just the explanation is that, oh, they're alternate interior angles. So you only had to do the 2. So let's get into the lesson. Now, quick review. On Thursday, we learned the exterior angle theorem for triangles. What it basically says is that this right here, this angle, is equal to these 2 angles added together. And I hope that makes sense because this is a straight line. So we take this, subtract from 180, it must equal this. And the same thing, this has got to be 180 degrees in here. So whatever these two have to equal that. They have to. So that's what we learned on Friday, and we went through the proofs to fully explain why. So what you're going to be doing today, we just did the warm-up and you checked your preview review. We're going to investigate the angle criterion for similar triangles. So again, we're taking the next step. We're going to use what we learned last week Monday, last week Tuesday, last week Thursday, and we're going to extend it. We're going to keep that knowledge going. So again, make sure you're asking questions. And you might say, Mr. Rattoon, how can we ask a question if we're not there? Maybe you jot them down. I should be back to school later in the day. You can always ask me during when if you're struggling. But we're going to look at things like words like the exterior angle theorem. We're going to explore triangles again today. We're going to still talk about remote interior angles. You're going to have to justify your answers. We're going to look at scale factors, and then we're going to be learning about angle-angle similarity. So we're going to be doing these. When you get done, you've got some review preview to do, and you've got some IXL, and then keep in mind, you've got 2 iReady lessons to do this week. So without any fanfare, let's go ahead and get started. So the first thing I'm looking for at 939 is it says using a sheet of graph paper, and you have the graph paper already in your pocket. What it wants you to do is plot these points here. So take these points, put them on your graph. And I want you to label them M, N, P, and Q. Now we're going to work a lot with M and N, so I'm going to label those, and I'm not going to label P, Q, but go ahead, label them on yours. Then what you're going to do is you're going to enlarge the quadrilateral by a factor of 2. So some people read this as, oh, I take this and I'm going to plot this. Plot this and then plot this. So you should have 2 quadrilaterals on this graph. So that's what I'm going to be looking for, and that's what the questions are going to ask you about. So go ahead, pause the video and complete that. All right, so we're going to move on. Now, if you're just skipping and you're just looking at the answers, well, tough, because you still have to plot these, and I'm looking for that on your graph paper if I decide to check. So A says using a sheet of graph paper and a straight edge, graph the quadrilateral here. So we just did that. So this is what it would look like. This is your answer for A, and so this is what I'm looking for. Now B says, what do you notice about side M and N and M1, N1? So what this tells us is this is the original, and these are the copies. So what do you notice about side MN and side M1, N1? And I'm going to go ahead and talk about this question right away because the answers are on the next page. What can you say about M and M1? Explain your reasoning. So go ahead, pause the video and answer that, and unpause the video when you're ready to see if you answered correctly. All right, so you should have found that when you look at MN right here and you look at M1, N1, they are parallel. Why are they parallel? Well, they both have the same slope and they have a different y-intercept, and you can see that right here. So the hint down here that says hint, extend the lines, all they wanted you to do is, all it was saying, let me grab a different color pen. Oop, I want to grab a different color again. Is if we extend these lines out, it just wanted you to notice that they're parallel. That's what it means by that. Now, what can you say about the angles? So this angle right here and this angle right here. Well, if they have the same slope, and if these are also parallel, they're equal. They're the same. And you might be wondering, that sounds familiar. We actually talked about this a few chapters ago. And if we enlarge something, or when we talked about dilations, they can get bigger and smaller. So if we dilate something larger, if we enlarge it, the lengths aren't going to be equal. The area won't be equal, but they continue to be parallel, and the angles are going to be the same. So let's look at D. Remember that a conjecture is an inference or a judgment based on incomplete evidence. Based on your work in this problem so far, make a conjecture about the angles in similar figures. Well, we just learned that the angles in similar figures are equal, and you'll see the answer on the next slide. Then E says, test your conjecture in part E using a figure of your own. So I would just draw something really small over here. Could be a triangle that you enlarge, could be, don't do a circle. Do it like a square, a rectangle, a triangle. And what it really wants you to do is when you enlarge it, you should notice that everything we learned over here is the same, that the angles are going to be the same. And so the answer for D was the corresponding angles in similar triangles are equal. So what we just did is this sets up the entire lesson for today. This is the backbone of what we're going to learn. So, problem 40. Imagine that two pairs of corresponding angles in two triangles are of equal measures. What could you then conclude about the third set of angles? Justify your answer and draw a diagram. So I already drew a diagram on mine, but if you look in your packet, you do not have a diagram. I would just draw two triangles. So what can you conclude about the third set of angles? What it's really saying is, let's say this angle is 60. So again, imagine two pairs of corresponding angles and two triangles are equal. So let's say this is the corresponding angle here. Kind of looks, but that's a 60. And let's say this is also 60. Down here, and the corresponding angle is 60. It says, what can you conclude about the third set of angles? Justify your answer and draw a diagram. So we know if these two corresponding sides are equal, and if this corresponding side is equal, what can we conclude about the third angle, the third set of angles? And if you're thinking, I don't know, well, think about it. The total measure of all these angles is what? 180 degrees? And the total measure of all these angles is 180 degrees. So if these two are equal and these two are equal, they both equal 120. And if I take 180 minus 120, that means that these both must be equal because they're both going to be 60. They have to be. And what this is telling us is that if you can prove that two angles in a triangle, if two angles in a triangle are congruent, if they're the same, if they're equal, then the third one must also be equal. It must. You don't have to worry about finding it. You know it's equal. You know it's equal. So let's put that to the test. And let's put this in words. So it says, use your conjecture for part E of problem 9-39 along with your work from problem 9-40 to explain how you can use the angles in a pair of triangles to determine if they are similar. Be sure to include how many angles you need and what needs to be true about them. So this is how we can put it into words. If two pairs of corresponding angles are of equal measure, then the triangles are similar. So again, I'll come back to this, but if we back up here, as long as we can prove in a triangle that two angles are similar or are the same, the third one must be the same. Therefore, the triangles are similar. Because if you remember, we backed up here. When we dilated this, we learned that, yeah, they're parallel. They're not same length, but the angles are the same. And if the angles are all the same, they are similar. We proved it here because we proved that if these two, we talked about if these two are the same, the third must be the same. And that means that the triangles are similar. So let's put that concept to the test. Here's a challenge problem for you. It says the relationship in the previous problem is called angle-angle similarity. And if you want to write it shorthand, you write it just like this right here. It's angle-angle similarity. The symbol right here means similarity or is similar to. So right here we know that angle ABC is similar to EDC. That is, triangle ABC is similar to EDC. So that word, that symbol right there really means similar. So how could we prove, because it says they're similar, how do we know for sure? How can we prove this? Beyond a reasonable doubt. Now, first of all, go back here. What we must do is prove that two of those angles are equal. And as long as we can prove that two of these angles are equal, it's similar. So here's how we do it. We know that this one right here is 90 degrees. We know that this is 90 degrees. So if I start to explain my reasoning, I know that angle B is equal to angle D. They're both 90 degrees. Well, we don't know what A and E are, but let's look at C. And if I was going to label these, I would label it, how about we label it angle A? We just learned how to do this on Thursday. Nope. Let's label it ACB. So ACB is right here. And if we're going to do that, we have to label the other one angle E, C, and D. Now, the reason why we label the angles this way is we can't just say, oh, it's angle C. Well, what angle C? Is it this one up here or is it the one down here? So what do we know about these angles? So I'm going to go ahead and erase a little bit of this right down here. What do we know? What have we learned about this area right here? What kind of angles are these? These are called, and think about it. If we extend this line right here, and we extend this line here, because these are both 90 degrees, we know these lines are parallel. So we can start to take a look. What type of angle would this be? If you said it's a vertical angle, you are correct. So we know that these angles are equal. We know it. They're vertical angles. So if we know that these two are equal and these two are equal, that means that angle A must equal angle E. They have to. As long as we can prove that in a triangle, two of the angles are equal, the third one must also be equal, and that's the angle-angle similarity. So in this figure at the right, is triangle ABC similar to triangle EDC? I might have misspoken before saying it is. It's asking, is it? And the answer is yes. And you might be saying, well, how is it? Yes, again, we prove that two sets of angles are equal, so the third one must be. Now, we don't know the measures of these two angles, but we can at least say that they're similar. So let's move on to our last problem here. This is, again, putting everything together. Eleanor and John were working on a geometry problem together. They knew that in the figure below, line M is parallel to side BC. They wanted to find the side lengths of each triangle. First, they decided that they needed to show that triangle AED is similar to ABC. So they needed to show that they're similar. Eleanor thought, this is easy. We have parallel lines, so the triangles are similar by angle-angle similarity. Hold on a minute, John replied. Which angles are equal? So the first thing I want you to do is use the diagram that you see here. What two angles did Eleanor see? Why are they equal? So let's take a look at these and think about it a little bit. We know that these two lines are parallel. We know it because they have these parallel markings. So if we know that, and then this is a transversal, we know that these are corresponding angles. Let me just put a different color there. So we know that this angle and this angle are corresponding. And if those two angles are corresponding, we know they're going to be equal. Now let's look at it from the other side. If this is the transversal, oof, that was really off. We also know that this angle right here and this angle right here is also similar. And furthermore, if we look at this angle right here has to be, I'm sorry, it's not similar. They're equal because they're corresponding angles, which means this last one too must also be equal. Yeah, because of angle-angle similarity, but also because they're the same angle. Both triangles end right here, so they have to be equal. So that's why Eleanor said everything was easy. So what would I write? I would write down right here that angle B and I would go angle 1 are similar or are equal because they're corresponding. Then I'd say, and it's right here, it's 2, I would say that angle C and angle 2 are equal because they're corresponding. Then I'd write that angle A are identical, or the angle A on both triangles is identical, and you see that right here. So here's where it's a little test. Are you able to write that down just because I'm speaking it? Because I know I've got some people in science that never listen to the videos. They just put it on mute because they don't have their earbuds. And then if they don't write anything down because it's not written down. So this is what you could get busted on if you don't have this filled out. So let's move on. Are triangles AED and triangle ABC similar? Yes. So this is what you write for that. They are similar, or you can say triangle AED and triangle AB or ABC are similar because of, and this is what you write. So write down this part right here and say that triangle AED and triangle ABC are similar because of angle similarity. So we know they're similar because of this right here. So let's move on. Now that John sees how the triangles are similar, he suggests redrawing them separately as shown at the right. Look, he says, now we just write a proportion. He suggested the following equation. So when we look at the measurements, this is what he wrote. Explain how John came up with this equation. Well, look at it. The 3 comes from here, and AE is corresponded to AB. So this comes from this side right here. X is right here, and this is this side right here. So go ahead and write that. How would you write it? I would say, well, 3 corresponds to 3 plus 5, and X corresponds to X plus 8. So when we solve the proportion equation in part C for X, and check your answer. So solve the proportion right here for X. So let's go ahead and do that. So I'm going to go ahead and erase this right here because we're going to solve it right up here. So remember how to solve these? Remember, you can cross multiply. So what does this equal? This equals 3x plus 5x. Then we got to multiply this part, and you got to distribute it, equals 3 times x is 3x. What's 3 times 8? 22, right? You better not write 22 down. It's 24. So this is the proportion we have. Now, can you solve it from here? What I'd like you to do is go ahead and pause the video, try and solve it, and then restart it up when you're done. All right, so what did you get? How did you solve it? So if I subtract, well, first of all, let's CLT this. So this is 8x, right? equals 3x plus 24. Subtract 3x. Now we can subtract 3x from this side. Is that what you get? Yep. Did you get 5x? What did you get on the other side? If you said it's 24, yep. Now you might be looking at this and say, oh, this doesn't work out properly. Still do it. Still solve it. Now, easiest thing to do, we know that this cancels out, so it's x. Just take a calculator. What's 24 divided by 5? You should come up with 4.8. Could you leave it as a fraction? Sure. If you said, oh, it's 5 and 4 and 4/5, I'd also accept that. So I'd accept either one. All right. So again, hopefully you have everything filled out. Hopefully what I've explained makes sense. If not, make sure you ask during winter, ask during class tomorrow. What you're going to be doing now is you're going to be doing problems 47 and 49 in a review preview. Again, make sure you show all your work. Make sure you do everything that you're supposed to do. You know, when you look at problem 47, you're going to have to, and we practice drawing these. It's a stem and leaf plot. No, it's a box plot that you have to draw there. It is a stem and leaf, or it's the cat whisker one that you have. So it's a box plot. And then down below, make sure you show your work. It even says show all work. So you can't just work with a partner and copy down their answers. That will not work. Once you get that done, finish up these two IXLs. Now this lesson is going to be done in record time because you're supposed to be pausing the video, so hopefully you don't have that much time left. And then remember, if you get done with these, go ahead and work on those lessons, and maybe you can get one done today during class. So go ahead and get started on the review preview, and go ahead and do the IXL and then do the iReady. So again, if you have any questions, come see me during winter. Ask me tomorrow. Bye.